All right, now it's time to add a couple of rational expressions that have unlike denominators. So first thing we always do is look for a lowest common denominator. Now, if you remember correctly, we've kind of looked at this problem before and found out that 6x squared and 9x, its lowest common denominator was 18x squared. So what we can look at that is use that to second rewrite each expression as a term over 18x squared. So to choose the first one, if I have 7 over 6x squared, and I need it to become over 18x squared, I need to multiply this one by a clever version of 1. I need to multiply by a 3 over a 3. Again, any fraction when multiplied by 1 maintains that same value. So my equivalent fraction will be 21 over 8x squared. Looking at the second one now, if I have 2 over 9x, and I need it to be over 18x squared, I'm going to multiply this one by 9x times what makes it 18x squared? It looks like a 2x. So I'll use that as my clever version of 1. So I'll multiply this one by a 2x over a 2x. The denominator becomes my lowest common denominator that I'm searching for. The numerator becomes a 4x. So now what I can do is I can rewrite this expression in its equivalent form. 7 over 6x squared is the same thing as 21 over 18x squared, plus 2 over 9x is the same thing as 4x over 18x squared. There I have common denominators now. Step 3, add or subtract depending on what it's asking me to do. 21 plus 4x, that becomes 4x plus 21. Typically, we like to write our terms in descending order of our x's, and then over an 18x squared. And then lastly, simplify. Simplify means, is there any common factors in the numerator and the denominator? 4x plus 21 does not factor, meaning I can't find anything that goes into the 4 and x and the 21, so it does not factor, and that factor is not common with on the bottom. So my final solution then is 4x plus 21 all over 18x squared. Hey, we need a little happy face with that one. That was kind of fun.